Here's 2017 question 3. This is a graph analysis problem here. Right away, I noticed that the picture, the graph, represents f prime. So just keep that in mind for later, okay? Here we go. Find the values of f of negative 6 and f of 5. Okay, how do we get f if we start with f prime, right? So we know we're going to have to integrate f prime. Okay, now from where to where? So on top, you put what you are interested in or what you want, and you plug in what you're given. Okay, so notice how what we're given here is f of negative 2. This is our given condition. Okay, so what we want to do here is we want to plug in negative 2, but that means you have to consider where you started. So at f of negative 2, that's going to be a positive 7. Okay, what you're interested in, separately, you're going to put in negative 6 and then 5. Okay, so negative 6 here, and then later on we're going to do it with 5. Okay, but we'll start off with this. Notice how the bounds here are a little bit backwards, so I'm going to go ahead and reverse that just so it looks a little bit easier to understand. So this is what I have here for f of negative 6. What does it mean to integrate, right? When you integrate a graph, you're really finding the area under the curve. So in this case, we're going from negative 6 all the way to negative 2. Notice how that area is above the x-axis, so we know it's going to be some positive area, okay? That is the area of a triangle, which is just 1/2 times the base, which is 4, times the height, which is 2. That's enough for equals equal, but if you want to crank that out, you'll get 3, like the scoring guidelines here, okay? Now, next, well, what if I were to plug in 5, right? Notice how the bounds are actually proper here. You're going from left to right here, but let's take a look at what areas we uncover here. So if we go from negative 2 all the way to 5, I actually have two shapes here. I have a semicircle that's below the x-axis, so I know that's going to come out negative. And over here, I have a triangle above the x-axis, so I know the area is going to come out positive. To the left here, this is a semicircle, so that's pi r squared over 2. The radius is 2. Okay. The area of this triangle here is 1/2 times the base looks like it's 3, the height looks like it's 2. Okay. So basically you could just write negative pi 2 squared over 2 plus 1/2 times 3 times 2. Plus, don't forget what you started with, that's 7 plus. I would just leave it there, okay? Even though you could clean it up a little bit. But that's pretty much it for part A. Here's part B. On what intervals is f increasing? Okay, very straightforward question. F will increase when f prime is positive. So look, you have the graph of f prime here. Let me get rid of this here so you guys can see it. Where is f prime positive? Pretty much above the x-axis from here to here, here to here, here. Okay, so we're going from negative 6 all the way to negative 2, and then we're going from 2 all the way to 5. How do we know that? Since f prime is greater than 0. Okay, that's basically it. All right, part C. Find the absolute minimum. So this takes a little bit of work because there's a lot of computation. Remember, absolute extremas can occur at the endpoints and at a critical number, okay? So in this case, we have 3. If you look at the picture, this is where the derivative is 0. We have this, this, and this. So what you can do, you could kind of rule stuff out if you'd like. So initially here, I'll put in negative 2, 2, and 5, okay? Now, if you take a look, this right here, the derivative goes from positive to negative. Right here, the derivative goes from negative to positive here. We could actually rule out this one because that is a local max. Okay? There is no way that a local max can be an absolute minimum. So you could actually rule out -2. It can save you a lot of time, so just keep that in mind. Now here, we're trying to find the absolute minimum of f of x. So f of x is going to require that you guys integrate f prime, kind of like how we did the first problem, from some number to what you started with. So remember, what we started with was -2. That's our given condition. And at -2, we started at 7. Okay? So there's a lot of plug and chug here. I'll do the first one. This is going to be 7 plus the integral from -2 to -6. Okay, and we actually did that in part A. It came out to 3. Okay. F of 2, we haven't done just yet. That's 7 plus the integral of -2 to 2 f prime of x dx. Let's take a look at that there. That's going to be 7 plus, let's go back to the picture, from -2 to 2. That's really just that semicircle, okay, which is just pi 2 squared over 2. All right, and we did notice that the area was negative, okay, below the x-axis. All right, last one here. F of 5, I believe we did f of 5 as well. It came out to 10 minus 2 pi. Okay, so we're looking for the absolute minimum value. Okay, so this one here came out to 3. This one here, you kind of have to simplify. It came out to 7 minus 2 pi. This one came out to 10 minus 2 pi. Okay, so which one's the smallest? Right? So you do have to estimate a little bit here. Remember, pi is like 3.14, so let's just assume that it was 3, right? So 7 minus 2 pi is really 7 minus 2 times 3, which is like 7 minus 6, which is like 1. It's about 1-ish, approximately 1. 10 minus 2 times 3 is 10 minus 6, which is about 4. Okay, so we know the minimum value is going to be 7 minus 2 pi. And your table is your justification. Okay, and here's the last one. For each of f double prime of -5 and f double prime of 3, find the value. Okay, so we're given the graph of f prime. Okay, so what does f double prime mean? Okay, it's really just the slope of that. Okay, so they're asking us, well, what's the slope at -5? -5 is right here, you guys. Notice how -5 lands right on a line. The slope is down 2 over 4. Down 2 over 4. There's your slope, okay? Now they're asking me to find my slope at 3. Notice how 3 lands on 2 different lines. It's actually a corner. So this one here is not differentiable. Doesn't exist. Okay, and that's basically it.